A moon landing is the arrival of a spacecraft on the surface of the moon. This includes both manned and unmanned missions. The first human-made object to reach the surface of the moon was the Soviet Union's Lunar 2 mission, on 13 September 1959. The United States' Apollo 11 was the first manned mission to land on the moon, on 20 July 1969. There have been 6 manned U.S. landings and numerous unmanned landings, with no soft landings happening from the 22nd of August 1976 until the 14th of December 2013. To date, the United States is the only country to have successfully conducted manned missions to the moon, with the last departing the lunar surface in December 1972. Unmanned landings. After the unsuccessful attempt by the Lunar 1 to land on the moon in 1959, the Soviet Union performed the first hard moon landing later that same year with the Lunar 2 spacecraft, a feat the U.S. duplicated in 1962 with Ranger 4. Since then, 12 Soviet and U.S. spacecraft have used braking rockets to make soft landings and perform scientific operations on the lunar surface between 1966 and 1976. In 1966, the USSR accomplished the first soft landings and took the first pictures from the lunar surface during the Lunar 9 and Lunar 13 missions. The U.S. followed with 5 unmanned Surveyor soft landings. The Soviet Union achieved the first unmanned lunar soil sample return with the Lunar 16 probe on 24 September 1970. This was followed by Lunar 20 and Lunar 24 in 1972 and 1976, respectively. Following the failure at launch in 1969 of the first lunar cart, Lunar E8 number 201, the Lunar 17 and Lunar 21 were successful unmanned lunar rover missions in 1970 and 1973. Many missions were failures at launch. In addition, several unmanned landing missions achieved the lunar surface but were unsuccessful, including Lunar 15, Lunar 18, and Lunar 23 all crashed on landing, and the U.S. Surveyor 4 lost all radio contact only moments before its landing. More recently, other nations have crashed spacecraft on the surface of the moon at speeds of around 8,000 km per hour, often at precise planned locations. These have generally been end-of-life lunar orbiters that, because of system degradations, could no longer overcome perturbations from lunar mass concentrations to maintain their orbit. Japan's lunar orbiter Hi-10 impacted the Moon's surface on 10 April 1993. The European Space Agency performed a controlled crash impact with their orbiter Smart 1 on 3 September 2006. Indian Space Research Organisation performed a controlled crash impact with its Moon Impact Probe on 14 November 2008. The MIP was an ejected probe from the Indian Chandrayaan-1 lunar orbiter and performed remote sensing experiments during its descent to the lunar surface. The Chinese lunar orbiter Chang'e 1 executed a controlled crash onto the surface of the Moon on 1 March 2009. The rover mission Chang'e 3 was launched on 1 December 2013 and soft-landed on 14 December. Manned landings. A total of 12 men have landed on the Moon. This was accomplished with 2 U.S. pilot astronauts flying a lunar module on each of 6 NASA missions across a 41-month time span starting on 20 July 1969 UTC, with Neil Armstrong and Buzz Aldrin on Apollo 11, and ending on 14 December 1972 UTC with Gene Cernan and Jack Schmitt on Apollo 17. Cernan was the last to step off the lunar surface. All Apollo lunar missions had a third crew member who remained on board the command module. The last 3 missions had a rover for increased mobility. Scientific background. In order to go to the Moon, a spacecraft must first leave the gravity well of the Earth. The only practical way of accomplishing this currently is with a rocket. Unlike other airborne vehicles such as balloons or jets, A rocket is the only known form of propulsion which can continue to increase its speed at high altitudes in the vacuum outside the Earth's atmosphere. Upon approach of the target moon, a spacecraft will be drawn ever closer to its surface at increasing speeds due to gravity. In order to land intact, it must decelerate to less than about 160 km per hour and be ruggedized to withstand a hard landing impact, or it must decelerate to negligible speed at contact for a soft landing. The first 3 attempts by the U.S. to perform a successful hard moon landing with a ruggedized seismometer package in 1962 all failed. The Soviets first achieved the milestone of a hard lunar landing with a ruggedized camera in 1966, followed only months later by the first unmanned soft lunar landing by the U.S. The speed of a crash landing on its surface is typically between 70 and 100% of the escape velocity of the target moon, and thus this is the total velocity which must be shed from the target moon's gravitational attraction for a soft landing to occur. For Earth's moon, the escape velocity is 2.38 km per second. The change in velocity is usually provided by a landing rocket, which must be carried into space by the original launch vehicle as part of the overall spacecraft. An exception is the soft moon landing on Titan carried out by the Huygens probe in 2005. As the moon with the thickest atmosphere, landings on Titan may be accomplished by using atmospheric entry techniques that are generally lighter in weight than a rocket with equivalent capability. The Soviets succeeded in making the first crash landing on the Moon in 1959. Crash landings may occur because of malfunctions in a spacecraft, or they can be deliberately arranged for vehicles which do not have an onboard landing rocket. There have been many such moon crashes, often with their flight path controlled to impact at precise locations on the lunar surface. For example, during the Apollo program, the SIVB third stage of the Saturn V moon rocket as well as the spent ascent stage of the lunar module were deliberately crashed on the moon several times to provide impacts registering as a moonquake on seismometers that had been left on the lunar surface. Such crashes were instrumental in mapping the internal structure of the Moon. To return to Earth, the escape velocity of the Moon must be overcome for the spacecraft to escape the gravity well of the Moon. Rockets must be used to leave the Moon and return to space. Upon reaching Earth, atmospheric entry techniques are used to absorb the kinetic energy of a returning spacecraft and reduce its speed for safe landing. These functions greatly complicate a moon landing mission and led to many additional operational considerations. Any moon departure rocket must first be carried to the moon's surface by a moon landing rocket, increasing the latter's required size. The moon departure rocket, larger moon landing rocket and any Earth atmosphere entry equipment such as heat shields and parachutes must in turn be lifted by the original launch vehicle, greatly increasing its size by a significant and almost prohibitive degree. Political background: the intense and expensive effort devoted in the 1960s to achieving first an unmanned and then ultimately a manned moon landing can be hard to understand in normal situations, but becomes easier to comprehend in the political context of its historical era. World War II, with its 60 million dead, half Soviets, was fresh in the memory of all adults. In the 1940s, the war had introduced many new and deadly innovations, including blitzkrieg-style surprise attacks used in the invasion of Poland and in the attack on Pearl Harbor, the V-2 rocket, a ballistic missile which killed thousands in attacks on London and Antwerp, and the atom bomb, which killed hundreds of thousands in the atomic bombings of Hiroshima and Nagasaki. In the 1950s, tensions mounted between the two ideologically opposed superpowers of the United States and the Soviet Union that had emerged as victors in the conflict, particularly after the development by both countries of the hydrogen bomb. Willy Ley wrote in 1957 that a rocket to the moon could be built later this year if somebody can be found to sign some papers. On 4 October 1957, the Soviet Union launched Sputnik 1 as the first artificial satellite to orbit the Earth and so initiated the space race. This unexpected event was a source of pride to the Soviets and shock to the US, who could now potentially be surprise attacked by nuclear-tipped Soviet rockets in under 30 minutes. Also, the steady beeping of the radio beacon aboard Sputnik 1 as it passed overhead every 96 minutes was widely viewed on both sides as effective propaganda to Third World countries, demonstrating the technological superiority of the Soviet political system compared to that of the US. This perception was reinforced by a string of subsequent rapid-fire Soviet space achievements. In 1959, the R-7 rocket was used to launch the first escape from Earth's gravity into a solar orbit, the first crash impact onto the surface of the Moon, and the first photography of the never-before-seen far side of the Moon. These were the Lunar 1, Lunar 2, and Lunar 3 spacecraft. The U.S. response to these Soviet achievements was to greatly accelerate previously existing military space and missile projects and to create a civilian space agency, NASA. Military efforts were initiated to develop and produce mass quantities of intercontinental ballistic missiles that would bridge the so-called missile gap and enable a policy of deterrence to nuclear war with the Soviets known as Mutual Assured Destruction or MAD. These newly developed missiles were made available to civilians of NASA for various projects. While NASA stressed peaceful and scientific uses for these rockets, their use in various lunar exploration efforts also had secondary goal of realistic, goal-oriented testing of the missiles themselves and development of associated infrastructure, just as the Soviets were doing with their R-7. The tight schedules and lofty goals selected by NASA for lunar exploration also had an undeniable element of generating counter-propaganda to show to other countries that U.S. technological prowess was the equal and even superior to that of the Soviets. Early Soviet unmanned lunar missions. After the fall of the Soviet Union in 1991, historical records were released to allow the true accounting of Soviet lunar efforts. Unlike the U.S. tradition of assigning a particular mission name in advance of a launch, the Soviets assigned a public lunar mission number only if a launch resulted in a spacecraft going beyond Earth orbit. The policy had the effect of hiding Soviet moon mission failures from public view. If the attempt failed in Earth orbit before departing for the Moon, it was frequently given a Sputnik or Cosmos Earth orbit mission number to hide its purpose. Launch explosions were not acknowledged at all.